Okay, fine. So this is the number system additional problems which we have done in the last CSAT crash course 2022. This we are going to discuss here again, just to give an idea, okay, how to solve. Suppose if these models comes in your examination. Nowadays, UPSC is not providing these models, but in your previous year and all, before to 2019 and all, there was a question related to this one. So therefore, we will discuss these models also here. So this is the first question. Okay, so here there are four consecutive prime numbers. The product, so this was asked in the UPSC 2011. Okay, the product of the first three is 385. Then the product of the last three is 1001. The first and last numbers are respectively. The first and last numbers are respectively. The thing is, the first you need to understand here. Okay, the product of the first three is 385. So to get a product in the unit place as a 5, obviously the 5 must be the one of the factor, right? So therefore, you understood, right? Why 5 here? 5 must be one of the factor. Then you need to check here. Since 2 and 3 is obviously not divisible by 385. So therefore, there are 4 consecutive prime numbers. You can take from 5. Okay. Why we are not taking 3, 2? So that is what I have explained this part. Okay. So the next part is 4 consecutive prime numbers. Okay. 5, 7, 11, 13. Then here I am checking here with the first statement. 5 into 7 into 11. 5 into 7 into 11. So obviously it gives you 385. So therefore the product of the last three, so therefore 7, 11, 13. So which is equal to 1001. So the condition satisfies. Here the question is first and last number respectively. The first number is 5, the last number is 13. So the answer for this question is 5 and 13. If you are having doubt, please clarify. Anybody having a doubt here with this question? Shall I move on with the next question? People, I'm asking you. Okay, fine. Let me move on with the next question. So next one. So this is a very important model. This model was asked in the previous year. Okay. Very important model. How many natural numbers up to 100 are not divisible by 3 and 7? Understand very carefully. The question is dealing with not divisible. Okay. Underline this one. Not divisible. The first thing what you need to do is, the first of all, to solve this problem, how many natural numbers up to 100 not divisible? So first of all, what we need to do is, we need to find out the numbers which is divisible by 3. Okay, since it is given 3 or 7, so therefore which is divisible by 3. So then how to do that? Listen carefully. This is the simple steps provided here. So divide that 100 with 3, take the quotient. So 33 is the quotient. Okay, don't take a decimal. So therefore 33 numbers are there. Okay, so number divisible by 7. Number divisible by 7 means 100 divisible by 7. Take the quotient alone. Therefore 40 numbers are there. Now the next thing is, you have found n of a, n of b. What you need to find here is, you need to find out the n of a intersection b. Okay, how to find a intersection b? Listen carefully. Here in this itself, there are 33 numbers are there. Here 33 numbers are there which is divisible by 3. Then here 14 numbers are there which is divisible by 7. There are some numbers common to both 7 and 3. that number is also present. Let me tell you that one. 21, simple example. The 21 is divisible by 3 and 7 also. That is nothing but both 3 and 7. So which means how many numbers are there means take the LCM between these two first. 21. Okay, divide that 100 with 21, there are 4. Okay, take the quotient. So therefore 4. You know the concept called as okay, first of all, let us find out the total numbers which is divisible by 3 and 7. So therefore n of A union B, which is equal to n of A. So this you know probability. Okay, n of A plus n of B minus n of A intersection B. If the question, listen, this option also there, 43 also there. Okay, n of A is nothing but 33, n of B is nothing but 14, n of A intersection B is nothing but 4. If you are subtracting this, you are getting 43. That answer also there in your option. You have to be very careful. The question is dealing with how many natural numbers up to 100 which are not divisible by 3 and 7. If the question is divisible by 3 or 7, then the answer is 43. But the thing is which are not divisible. Okay, so that is the thing you need to identify, which are not divisible by 3 or 7. So the answer is 57. So the answer is 57. Clear? How to get a solve this kind of problem? Yes or no? Here,
Yes, sir.
listen. Here, wait. I have provided you with a. Listen. Here is the question. Please solve this kind of question. How many numbers from 0 to 99 are not divisible by either 5 or 7? You people solve this question. Okay. I will just tell you the solution link also. Okay. These things and all we have discussed. I will show you. I will tell you. But learn this thing. Then let me move on with the next question. A lot of questions are there to discuss. So this is one model. So I have provided you the practice problem here itself. Now listen carefully. This is another model. This, if you know the series concept, you can use this one. I don't want you people to use this model. The best method is the previous method one itself. This method is enough. Okay. This method too not required. I'm just deleting this part. So now listen carefully. This kind of model you have done. Very important model, and also this is purely a procedural method, and method 2 also there. Okay, listen carefully. P, Q are all whole numbers. What could be the maximum possible value of Q in the given expression? Maximum possible value of the Q in the given expression. Actually, this is the given expression. Let me tell you the simple method to solve this question. The method 1. First of all, take your time to read this question. So then we will go with method 2. Simple method. We need to identify maximum possible value of Q in the given expression. Okay. So here 3P8, then 5Q7, then 2R9. So it gives you the 4 resultant is 1104. Okay. So obviously here, if you add this 15 and here 24, here it carries 2. So please remember, this is a shortcut method. So now listen carefully. 2 plus P plus Q plus R is equal to what? Here 0. Unit place is 0. Here check whether it carries 1 or 2. So how to check? Add this one first. Here 8, then 10. So to get 11, we need a 1. Therefore 1 should be carry here. So therefore 1. So 10. Now add these things. Okay. Add these things. So now the question is dealing with the maximum possible value of Q. Q. Then what you need to do is put a minimum value. Minimum value. Since P and Q are the whole numbers, if it is whole number, it contains 0 also. Then substitute 0 in the place of P and R. So therefore, listen carefully now. 2 plus 0 plus Q plus 0, which is equal to 10. What would be the maximum value? So maximum 2 plus Q is equal to 10. What we have to substitute here in order to get 10? 8 only we have to substitute in order to get 10. So this is the simple method to solve this problem. I hope this method, simple method, is understanding to everyone. So the procedural method I will teach you. Now listen carefully. Let me teach you the procedural method. Procedural method will help you to solve any kind of questions. That is why I have done procedural method here also. Listen carefully. So this is the unit place, and then this is the 10th place, and this is the 100 place. So this should be expressed in the terms of your place value. So therefore 300 plus 10p plus 8. So then, so like this we are doing. So what here it provided is 1104. Okay, then I'm adding this. Okay, I'm adding all the values. If you are adding these values, then 300 plus 500 plus 200, it will become 1000. Then you can take a 10 as a common, then p plus q plus r. Then here 24. This value has been provided as 1104. Then what I have done is I am adding these two, then I am subtracting here. Therefore 10 into p plus q plus r is equal to 80. Then cancel this. P plus q plus r is equal to 8. Here the question provides that it is a whole number. Here it is asking to find out the maximum value for q, which means that it's implicitly mentioning that, not explicitly. Please remember, it implicitly mentioning that you need to take p and r value as a minimum of your whole number. The minimum of that whole number is nothing but 0. Therefore, the p and q contains 0. In such a case, automatically q is equal to 8. Clear this question? Anybody having a doubt? Aman, then others?
No doubt.
Sir, clear, sir.
Clear. Fine. This is a very important model. I will give you a PDF after this class. Okay, listen carefully. So then this question. This we have done right now.
Yes, sir. Just now,
Yes,
yeah.
this question we have done right now.
12.
Okay. Okay, I am leaving this one. Then this question. Yes, this is a very important, very important. This question looks very simple, and a lot of confusion will arise how to proceed this question. If I am erasing this solution, surely there is what we say, there is a lot of possibility to make a mistake with this question itself. Listen carefully. The following sequence is generated by dividing 55 by a natural numbers. Then what would be the x? So the simple thing here is the 55 divided by the natural numbers. Natural numbers start with 1. If you divide that natural number with 1, okay, natural numbers start with 1. Okay, take that natural number as a 1, divide that 55 here. So this is the first step. So therefore remainder is 0. That remainder comes here. So listen carefully. When this 2 is divided, okay, when 55 is divided by 2, here 1 remainder. So therefore remainder by this. So therefore when you are dividing 55 with 2, you are getting 1. So therefore 3 also you are getting 1. Then 4 you are getting 3. Then 5 you are getting 0. Then next is going to be the x. That x, when you are dividing that 55 with 6, that is going to be the answer. So therefore 55 dividing with us 55 divided by 6, it gives you a remainder as a 1. That is the answer for this question. Clear this model? I will give you a time. Please look at this question. If you are having any issues, please clarify. Anybody having an issue with this question? No, right? I'm moving with the next question. This is also very important question. Very important question. Don't check the solution. First of all, go through the question first. How many triplets x comma y comma z satisfies the equation x y plus z is equal to 21, where x, y and z are natural numbers divisible by 3. Natural numbers which are divisible by 3. The first statement provided in the question is how many triplets you need to form. Okay, listen carefully. I will tell you the simple text, simple things. Okay, so it given as a x plus y is equal to 21. Then x, y, z are the natural numbers. Okay, so the natural numbers means which are divisible by 3. Okay, let me take this as a 3, 6, 9, 12, 15. Okay, then I am checking why not we take 18. I am raising a question. Why not we take a 18? I am raising one question.
So
So
then
the
one,
18 also are divisible by 3, right?
so
Why I am
then one,
stopping here with 15?
then one number will be zero. So we cannot take
Because we can't take another number as zero, sir.
Another number as 0.
We
Since the
can't.
question, yes, since the question is dealing with x plus y plus z is equal to 21, when you are taking 18 here, then obviously the another number is going to be the 3. It gives you sum as 21, but the third either y or z, okay, you need to pick as a 0. Okay, to avoid such a thing, 18 should not be there, or else greater than 15 will not be there. Okay, the first thing. After this, what we need to do is we have to check the triplets. The first, what I am going to do is I am checking with 3 first. 3 here, then 6, then 12, then 21. So therefore, with these you can form your triplets. How many triplets? So just form this with 3, 6, 12. This is one. Then reverse this one. 3, 12, 6. This is second one. Listen carefully. With 3 we can form this 2. Now with 6 we can form 6, 3, 12. Then we can form 6, 12, 3. Then with 12 you can form 12, 3, 6 and 12, 6, 3. There should not be any repetition. If there is a repetition, then double counting. So avoid double counting. So do like this. So therefore here 6. Then listen carefully. With 3 itself we have another set. So therefore 3 plus 3, 6, 6 plus then 15 automatically gives you 21. So with this find out the another triplet. 3, 3, 15. With this 3, 15, 3. That is also a possible. Again with the 3 you should not make it. Okay, since it's a double counting. Now we are moving with the 15. Therefore 15, 3, 3. So even 3, 3 comes now. Then that is also the same. Therefore here 3. Then with this 3 over. Then move on with the 6. So with the 6, any possibilities? Yes. 6, 6, 12. 12 plus 9, 21. So therefore we can form 669 and 696. So with this, fine. Then after this 6 comes in the 100 place, that is also a repetition. Then we put 9 in the 100 place, then we can form 6. So therefore here 3. So the next thing is about so now 3 completed, 6 completed, then we have to go with 9. With 9 we can take 9 plus 9, then 3. Okay, 18, 21. So now with this we can form 993, 939, then 399. So therefore here 3. So the total add 6, then here 3, 9, then here 12, 15. So therefore 15 triplets can be formed. Listen, you can say that we can go with 12. Okay, why not? Yes, you can go with 12. 12 plus obviously what will you take with the 12? 12 plus
Sir, 12, 6 and 3, sir.
That set is there na automatically.
Ha ha
Understood?
ha ha. Yes, sir.
Hmm. If you are taking 15, then also here there. So therefore, to avoid double countation, we have to stop here itself. Clear?
Okay,
Why
sir.
should not we take 12 in the first one? Since repetition is not allowed. Okay, double counting, to avoid the double counting, you have to stop it. I hope. Suppose if you are having a doubt where with this question, please clarify. No means I will move on with the next question. Shall I move on with the next question?
Yes, sir.
Okay. Listen, this model and all very important model. UPSC will put directly this kind of a simple question. But here you need to understand lot of things are there to understand with this question. If the numerator of your proper, please mute. If the numerator of your mute. If Rajeshwari mute. If the numerator of the proper fraction is increased by, okay, if the numerator of the proper fraction is increased by a positive quantity, that is the natural number, and the denominator is decreased by the same, then the resulting factor is, listen very carefully now. Let me take any original fraction, not only 1 by 5, you can take anything. Even you can take 2 by 5 also. Okay, take that as a, you can take anything. Okay, not only 1 by 5, you can take anything. Okay, so let us take 2 by 5 also. So what would be the 2 by 5 actual value? 2 by 5, 0 0.4.
4, sir.
Yes, let us take this as a original value. After this, read the statement. If the numerator of the proper fraction is increased by positive quantity, you can take it as a 1 itself, not an issue. Therefore 2 plus 1. When the same is decreased in the denominator, so therefore 5 minus 1, then it will become 3 by 4. 3 by 4 is nothing but 0 0.75.
0.7.
Now you can say that simply, you can say that 0.7 is greater than 0.4. Okay, or else you can say that 0.4 is lesser than 0.75. These two possibilities are arising. Now you go with the option. So the question is dealing with the resulting fraction is, the resulting fraction is nothing but 0.75. That is the resulting fraction. That resulting fraction is less than the original one? No, obviously wrong. The resulting fraction is greater than the original one? Yes, obviously that statement is right. Next we move on with the next one. Always equal? No. Such that the nothing can be claimed? Definitely. Here you can claim that the new one, resulting fraction is greater than the original one. You can go by taking any number of a fraction, any number of the proper fraction. A proper fraction is nothing but the numerator should be lesser than the denominator. So take in that model, you can put any number. Okay, so I have taken 1 in the numerator and then 1 in the denominator and adding there and subtracting in the denominator, and I am doing the thing. So it's a simple thing. Anybody having a doubt here with this one? No, right? Shall I move on with the next question? Listen, this is very important question. Very important question. How many such pair of 2-digit prime numbers are there in which the numbers are greater than 11 and mirror images of each other? Mirror images of each other. Okay, mirror images of each other. How many numbers are there? So let us check here. How many such pairs of 2-digit prime numbers are there in which the numbers greater than 11? So greater than 11, automatically it falls from 13. So mirror image of each other. So if you reversed this 13, so this is the mirror image. 17 is the prime number. If you reversed, which means the mirror image, it gives you 71s reversed. Okay. Since 31 is also a prime number and 17 is also a prime number. Okay. How many such a pair of two-digit prime numbers are there? Pair of prime numbers are there. So now listen carefully. 19 is a prime number, but 91 is not a prime number. Therefore, we are avoiding this one. Then 23 is a prime number. 32 is not a prime number. We are avoiding that. 29 is a prime number. Then 92 is not a prime number. We are avoiding that. 37 is a prime number. 73 is also a prime number. We are taking that. 41 is a prime number. But 14 is not a prime number. Therefore, we are eliminating that. Then 43 is a prime number. 34 is not a prime number. Therefore, you are avoiding that. 47 is a prime number. 74 is not a prime number. Avoiding that. 53 and similar way 35 avoiding that. 70. Okay, this is 57. Then here 75 is not. Then here it's also not. 61, 16 not. Then 67, 76, that is also not. Then 79. Then if you are reversing 97, that is the prime number. So how many such pairs are there? 1, 2, 3, 4. So there are 4. See, 4 pairs are there. It's a simple one, but my suggestion is you need to aware of a prime number concept. Prime number concept is very important concept for your UPSC. Not only UPSC, any competitive exams. Okay. So I'll give you a time. Please go through this one. If you are having any issues, please clarify this question, or else we will move on with the next. Shall I move on with the next one? Yes. This model we are done. Okay. This and all we are done. I'm skipping this question. We are done this question already discussed.
Yes, sir.
Then this question. Listen, this model, very important model. Actually, I have taken this question from CAT. Okay, CAT question. Okay, this was a CAT question. Yes, I have taken this one as a CAT one only. Yes, let me discuss this question. Possibilities are there. Nowadays, the CAT question is also coming here in UPSC. So that is why I have taken this one CAT question here. Listen, how many natural numbers are there less than 87 that are not multiple of any perfect square of numbers greater than 1 and up to 7? Not a multiple of a perfect square of the numbers. So first of all, you need to understand the perfect square of the numbers which is greater than 7, greater than 1. Okay, up to 7. So greater than 1. So what the perfect square number? 2 square. 2 square is nothing but 4. 3 square is nothing but a 9. Then 4 square, 5 square, 6 square, 7 square. So these are the numbers. Perfect square of the numbers greater than 1 and up to 7. So first of all, we are checking the multiples. The question is dealing with not a multiple. So therefore what we need to do is we need to take all the multiples, then we have to subtract from the given. Then automatically we will get the answer.
Sir, again explain the question now. Sorry.
Okay. How many natural numbers are there less than 87? Less than 87 means up to 86. Please remember, there is a possibility to make a, see, I will tell you why 86. See here, why 86 minus. Since less than 87, not given the as the less than or equal to 87, the question clearly says less than 87. Therefore, you need to check up to 86. Okay. That are, okay, that are not a multiple of any perfect square number, which means that first of all identify the perfect square numbers from greater than 1 to 7. So 1 square, okay, then 2 square greater than 1. So here I am not taking 1 here. Why I am not taking 1 means greater than 1. That is why I am started with the 4 here. So therefore perfect square. Therefore 2 square. Perfect square means 4. 4 is the perfect square number. Then 9 is the perfect square number. 16 is the perfect square number. 25 is the perfect square number. 36 is the perfect square number. Why I am taking 49 means the question deals with up to 7. So that is why I am taking 49. If the question is dealing with greater than 1 and lesser than 7, then we have to stop from 36 itself. Stop with the 36 itself. Clear? Huh? The difference between the words?
Yes, sir.
Very important. So now listen carefully. So then first of all we are checking that multiple of a perfect square numbers are there, which means that so therefore the multiples of 4 which is less than 87. How to calculate that? Simple. Listen, the simple technique to solve this is provided here itself. Okay, check with the 4 table, okay, which gives you less than 87. So less than 87 obviously 84. So 4 into dash is equal to 84. 4 into 21 is equal to 84. Therefore 21 numbers are there which is multiple of a perfect square. The perfect square number is nothing but the 4. That 4 tables, how many numbers are there which is less than 87? That is the question here. So here 21 numbers are there. Similar way, listen carefully here. 9 is very important. 9 is very important. Listen. So therefore 9. So now listen carefully. 81, right? So 9 into 9, 81. So therefore 9 numbers are there totally. But there is some repetition. If you are blindly take 36 and 72, it is called as a double counting. To avoid double counting, since why we are avoiding this one, since it already present in the multiple of 4, therefore you should not take here. Since if you take this one, it will become a double counting. Since the question is dealing with the already it's a multiple of a perfect square number. Since 36 and 72 it's already a perfect square number multiple, 4's multiple. Therefore here you should not consider in the 9. So therefore here totally 9. Then eliminate 36 and 72. Therefore you will get a 1, 2, 3, 4, 5, 6, 7.
7.
Therefore 7 numbers. Clear with
Okay.
this point?
Yes, sir.
Fine. Now listen carefully. Next one, 16. All the 16 tables are present in the 4 table itself. Therefore 0 here. Clear? All the 36 tables are present in the 4 table itself. Then therefore 0 there. 0 there. Then 25. 50, 75, 25. So therefore 3 numbers are there. 49. Only one number. 49 itself. Therefore 1. So now add this everything. 21, 7, 3, 1. Therefore 10, 11 and 21, 32. So therefore the question is not dealing with the how many natural numbers are there less than 7 that are multiple of perfect square number. If the question is dealing with that are multiple of a perfect square number, then the answer is 32. But the question is not the multiple. Therefore what we need to do? Less than 87 means 86. Therefore total 86 numbers are there. From these 86 numbers, how many numbers are present which are not a multiple of a perfect square number? Therefore, we have to subtract the numbers which are multiple of a perfect square. Therefore, there are 32 numbers are there. I am subtracting from 86. Therefore, we are getting 54. Therefore, 54 such a numbers are there which are not a multiple of a perfect square number. Simple example, you can say any number. Please, you can say any number which are not a multiple of a perfect square number for less than 3, less than 87. You can say 3. 3 is also your natural number which is less than 87, not the multiple of a perfect square number. Like this, you can say any other number. 5. You can say 6. Yes or no? 6 you can say na. 6 is a natural number which are less than 87. Yes, correct. 6 is not a multiple of any of the perfect square number. 4, 9, 16, 25, 36, 49. Isn't it? Like this, 54 such numbers are there. Understood? Having doubt? listen. Wait. This question also you people do. A number obtained by interchange the digit of the two-digit number which is less than. You people tell me the answer by seeing this one. Difference between them is 3. All the cases go with option method. Go with option method. You people answer this question. All the cases difference is 3. Check with the reverse. What is the original number? Take the original numbers. Reverse that. Check the difference. Check whether it gives you 27 or not. How many such?
Sir, 63. 63, sir.
Why not 52? Why not 52? Why not 52?
Difference between 6 and 3 is 3. So
Huh?
5 and 2 also 3.
See, every cases difference
it's
between these two
in
is
every
3
case.
only, right?
Yeah, yes, sir.
Huh? In this situation, listen carefully. If you mark any one of the answers, you'll get a off mark.
So D.
Yes. In this situation, if you mark any one of the options A, B or C, you will get a off mark. If it is 2.5, then you will get a 1.25 mark. If you go with D, then you will get a 2.5 mark. If the question is dealing with all of this, then what would be the answer?
All of these.
All of this would be the answer. Hope everyone is getting the point. Clear? Understanding, huh?
Yes.
Okay, now listen carefully. Simple question. Whatever I have discussed so far, that 10 minutes, that question, that concept applies here. How many numbers are there less than 100? But that question which I have discussed previously, that was less than 87. Here the question is dealing with the less than 100. That cannot be written as a multiple of a perfect square number greater than 1. Greater than 1. In this case, will you stop with 49? Will you stop with 49? Tell me the perfect square numbers first. 4. Then,
4, 16,
huh?
9.
You can go 64. You can take 81 also. Understood? Huh?
Up
Yes.
to 81, sir.
Up to 81 you need to take. The next thing is from which number you will subtract the multiples of a perfect number, perfect squares.
99.
Yes, very good. From 99 you have to subtract. Clear, huh? This question? Yes or no? These are all practice questions I have provided last time. I am giving you this here. Okay, listen carefully. Next question. Let me discuss a question, then I will give you this one. Okay, listen. Listen, this is also very important model. Then, yes, this one we have done, right? You people answer this one. The sum of the two digit is 11. All the cases 11. Okay, fine. If 45 is added to the number, the digits are getting reversed. 45 is added to the number, the digits are getting reversed. Find the number. 45 added
38.
38.
38.
Clear? Simple one, right? Here and all you can go with options, okay, rather than doing the proper method by taking original number as a 10x plus y. These things and all not required. Now listen carefully. This question we have done. How many numbers from 0 to 99 are not divisible by either 5? So this already discussed. Now listen. This question. A two-digit number is such that the product of the digit is 8. Product of the digit is 8. When 18 is added to the number, the digit getting reversed. Find the number. Find the number.
24.
24. So the product is 8. So listen carefully. This we can eliminate. This we can eliminate. Clear? Why I am eliminating C and D? Two-digit number such that the product of the digit is 8. Okay. So therefore, this product gives you 16. This product gives you 12. Therefore, you can eliminate easily. Then first one, A gives you 8. Then B gives you 8. The product. The thing is what you need to check. When 18 is added here, it is not getting reversed.
36 will get
Okay. 24, if you add this one, you are getting 42. Yes. This
42.
24 getting reversed as a 42. The answer is 24. Clear? This one. So next question. So this co-prime concept. This you people try. Okay. I have explained the solutions. Okay, I will give you that video link and all. But listen, this you people try this one. Then the number consists of the two digit of the place or integer. The number is added to the then this one. Sum of the digit of the two digit number is 10. When digits on the 21st. You people try these questions. I will give you the solutions. Now, let me discuss this question. This question we have already discussed. I think the part 4 class we have discussed this one. This is the recent trend of UPSC question. This was appeared. This model was appeared in the 2021. Okay, this model exactly. This model. So now listen this question. Now, few questions are there. From this we will discuss. This we have done. This we have done now. Okay, fine. Still 6 questions are there. We will discuss 6 questions. Then we will wind up. Okay. Now listen. A person had to multiply two numbers. This is very important model. Very important model. This concept very important. A person had to multiply two numbers. Instead of multiplying 33, the person multiplied 51. The product went up to 360. What is the raised product? What is the raised product? So, first of all, let me tell you the simple logic. A person has to multiply two numbers. Instead of multiplying 33, the person multiplied with 51. So, therefore, the correct one is 33x. Okay. Correct one is 33x. Please hear my words clearly. This is the correct one. So, this is the wrong one. Or else you can take it as a raised product. How to solve this question? Listen carefully. The step number 1 is find the difference between them. Find difference between them. Difference between them. So that was given in the question itself. The difference between them is 380. Okay. So therefore 51x minus 33x, which is equal to 18x. So 18x is equal to 380, x is equal to 20. The question is what would be the raised product? Raised means 51x. Therefore 51 into 20 automatically 10. If the question is dealing with the original or else correct product, then the answer is 33x. Clear? This concept?
Can you repeat one more time?
Okay, fine. Listen carefully. Actually, you need to multiply two numbers. Okay, one number is 33, other number is x. If you multiply this, you will get some value. But instead of 33, you have multiplied 51 with this x. Therefore, after this multiplication, the product went up to 380. which means that the difference is nothing but a 360, sorry, not 380, 360. The difference, okay, what would be the difference? 18x is the difference, is nothing but 360, then x is equal to 20, x is equal to 20. The question here is what is the raised product? Raised product means the 51x. What would be the original product means then 33x. Okay, so now listen carefully. If you understood this question, listen carefully now. Not this one, not this one. Here one question will be there, check here. Not this one, not this one, not this one. No, no. Tell me the answer for this one. Read the question carefully and answer.
One zero five zero.
1050. Any other answer?
1050, sir.
18x is equal to 540.
540.
X is equal to 30. Yeah.
30. Yes, sir. 30
So
into 55.
then 53x. But the question is, this is the original one, this is the raised one. Check with the question now. The question is dealing with the original product. Then what you need to find out? 35x. 35 into 30. Clear, huh? This one. But if the question is dealing with the raised product, then you have to multiply with the 53x. Clear? The difference between these two?
Yes, sir.
Okay. Fine. Next one. This one done. Next one. Listen. This is also very exact question was asked before 2019. This model was asked in your examination. This was present in your school book, NCERT book. Exact model provided there in your NCERT book. Now listen. If 1 is added to the numerator of the fraction, it becomes 7 by 19. If 1 is added to the denominator of the fraction, the value becomes 1 by 3. What would be the original fraction? Exact question was there in your NCERT. Listen. So let me take that original fraction as x by y. 1 is added to the numerator. Nothing happened in the denominator. So therefore, after this, it will become 7 by 19. So rearrange this with a, take this as a one equation. Okay, I will tell you the procedure. This already we have done in the our number system part 1 class itself. We have discussed this model. Then, so when nothing is added in the numerator, when it is added with the denominator, 1 is added with the denominator, it will become 1 by 3. Then get the second equation. Solve this equation, get the value of x and y so that you can get the original fraction. Clear? This one. Elimination method and all you people know, right? Many times done elimination method, substitution method. Now this question. This question is important. Important question. But okay, fine. Yes, rare cases, rarest cases, possibility there. Let me explain this one. What is the least fraction number which must be added to 28 by 11 plus 15 by 16 to make the result as a whole number? Okay, make the result as a whole number. First of all, 28 by 12 plus 15 by 16. First, what I am doing is, first of all, you need to take a LCM here. Okay, here LCM is 48. With this itself, you can eliminate the 50% of the option A and B eliminated. So in order to make a 48 in the LCM, here I have to multiply 4. Therefore I am multiplying here 4, then it will become 112. Then here 3 times, then I am multiplying here 3 times, then it will become 45. Then 157 by 48. Then you need to check which gives you a whole number, which does not gives you a whole number. 157 by 48 plus either 35 by 48 or else 17 by 48. So after I am substituting 35 by 48, I am taking a LCM again. 192 by 48. It's a completely divisible. It gives you a whole number. Here, when you take a 17 by 48, 174 by 48, it is not a whole number. It gives you a mixed fraction. So therefore, that is not the answer. Okay. So clear this question? Next question. Very important model. Very important model, this one. Listen carefully. If natural numbers are arranged row wise in a given manner, R1 1%. Okay, one number 1 will be in the R1. In the row 2, 2 and 3. In the row 3, 4, 5, 6. In the row 4, 7, 8, 9, 10. So like this. What will be the last term of the R10? Row 10. Row 10's last term. That is the question here. Okay. The simple thing is R1, right? Listen how to solve this question. R1 1, R2 like this last term of R10. So this is the question. So first of all, understand here. Last digit of R1 is equal to 1. Okay. Last digit of R2 is equal to 3, right? How could you get the 3? Summation of that row 2. Okay. Summation. Okay, Z2. Summation is nothing but 1 plus 2. Therefore 3. So check with this 5. Sorry, to get a 6. What we have to do? Summation of 3. Summation of 3. That is nothing but the last term of the row 3. Summation of 4 is nothing but the last term of the this one. So like this, you need to find out the summation of 10 in order to get the last term of the R10. So therefore, summation of the 10 is nothing but add this 55. Yeah. Then answer is 55. I'll give you time here. Please go through and clarify. I will wait. Understood this point? You should not listen. I will tell you one simple thing. You should not add 2 and 3. You should not add 4, 5, 6. You should not add 7, 8, 9, 10. The thing is, summation up to 1 is summation 1 is nothing but the row 1. Summation 2 is nothing but the row 2. Summation 3 is nothing but the last term of the row 3. Understanding this one? Or else you can go with manual. You can go with manual also. How to go with manual? Then go with R5. So like this you need to go R5. Okay. R5 what you need to do? 11, 12, 13, 14, 15. Understanding? So R5 last term is 15. Clear? R6 last term 16, 17, 18, 19, 20, 21. Clear?
Yes, sir.
So like this you need to find out. Okay. So instead of wasting the time, the simple method is find out the summation up to 10. Then that would be the last term. Next question. This we have done in our class itself. Okay. Then next one. Yes, this question. This question, listen carefully. This is also a concept called as a prime number. Wherever you find a prime number concept, take that question and solve. Then n plus 2 and n plus 4 are a prime numbers. Then the number of possible solution for n are read the question. Don't look the solution here. n plus 2, n plus 4 are prime numbers. The number of possible solution for n are. Listen carefully. If n is a natural number, then automatically it will become a prime number. How? Sir, you can take 1, but 1 is not a prime number. Okay, you can take a 2. 2 is also not a prime number. So that is why we have started here with the 3. So if you take a 3, then here 3, 5, 7, all are prime number. Okay, all are prime number. But the only possible solution for n is, the question is dealing with n. So n is equal to 3. So only one possible. Okay, you can say why not 4? 4 is not a, you can say you can 5. When you take a 5, then n plus 4 will become 9. That is not a prime number. So therefore the only possible solution here is n is equal to 3. Clear? Understanding or not? If you are having doubt here, please clarify. Or else you can clarify after this class also. Wait a minute, let me complete this one. Yes, very important model. You can see this model in your 2020 question. 2020 question. The pages, book concept and all there. Okay. Listen carefully. This question I will explain, very important model. So whatever I am discussing this 1 hour, it's a miscellaneous kind of a topics. Purely miscellaneous kind of a topics. So listen. Find the total number of the digit used in the numbering the pages of a book having 475 pages. Total number of pages. Okay, so how to understand this question? First of all, take a 475 pages book. Okay, there you need to identify how many total number of digits are used to number this. So the book always contains with 1. Okay, page number 1. Okay, so therefore the solution. Okay, so obviously from these digits only the book has been numbered, but you should not take a 0 here since it is start from 1. Okay, the book start from 1. So therefore I am taking the how many single digit number. So 9 pages are there in single digit number. So 2 digit number 10 to 99. What here? Simply calculate 99, then subtract the single digit. Single digits are 9. So therefore 99 minus 9. So it will become 90 pages. Okay, 90 pages are numbered with the 2 digits, 3 digits. So here please be careful here. 399 we have to subtract here 99 pages. Since single digit we have to subtract, then 2 digit we have to subtract if you are taking 399. Okay, so therefore 300 pages are there which are numbered with 3 digits. So but the question is dealing with up to 475. So then we have to go with a 400 to 475. 400 also counted, then here 75, therefore 76 pages are there. So 9 into single digit, then the 90 into 2 digit, then 300 into 3 digit, and again 76 pages, or else you can take totally 376 3 digit. So like this. So therefore for a calculative purpose I just splitted these things. So that 9 into 1 9, then here 180, then here 900, then here 288. So totally 1378 total number of digits are used to pay to number that 475 pages book. Clear this concept? Anybody having a doubt? So this is the last question. If you are having a doubt, please clarify.
Sir,
Hmm.
I was asking like why is it 300 into 3 and 76 into 3?
Huh.
I'm a
Three
little bit
numbers.
confused. Yeah.
There is nothing to confuse here. See, take a book. Okay, there are numbers. Okay, printed on the page. Okay, so the 3 digit number start from 100. Okay, we need to go with a 475. So here 100 up to 399, there are 300 pages are numbered there with the 3 digits. Then from 400 to 475, then 76 pages are numbered there. The question is, okay, how many such digits are there? So why you are multiplying 1 year, why we are multiplying 2 year, why we are multiplying 3 year, why we are multiplying 3 year? So that is the doubt of Bendilosa. Now listen, single digit, this much of single digit is with 9 pages. So first page contains 1, then 2, then 3, 4, 5, 6, 7, 8, 9. So totally how many pages are here? 9 pages are here, numbered up to 9. So that is called as 9 pages. Clear? Huh?
Yes, sir.
So that is single digit. Instead of calculating like this manually from 10, 11, 12, 13. So like this, it is quite difficult. Then what we are doing is we are finding out the total number of the 3 digits. Here 300 plus 76 totally is 376 pages are there. Okay. So 376 pages are there means you need to calculate from like this 100, then 101, then 102. So these are all quite difficult, 1 2 3. So like this you cannot calculate. So to avoid such a calculation, we are simply multiplying here 300 with the 3 digit. So therefore here 3, 76 with the 3 digits, therefore 76 into 3. Clear?
Yes, sir.
Okay. Any other doubt with the today's class? No doubt. If no doubt means I am concluding here. Thank you all. Have a good night.